Assuming you went through that dark opening, you would arrive at one more universe. There is presently an association between quantum processing and dark openings. In this enlightening video, we explore a groundbreaking and alarming discovery made by the James Webb Space Telescope inside a dark opening, explained by none other than Bill Nye the Science Guy. A dark opening is a star so gigantic that even light can't escape it due to its colossal gravity. The mysteries of dark openings have perplexed researchers for many years. However, now, thanks to extraordinary capabilities, we've seen something genuinely surprising. The Very Large Dark Opening consumes the equivalent of one Earth annually. This shocking and compelling, the very first picture of a dark opening in space. Brace yourself as we delve into the incredible details of this cosmic discovery and what it could mean for our understanding of the universe. Stars at the end of their life, much larger and more massive than the Sun, run out of fuel and start to collapse as gravity crushes them. Dark openings are difficult to detect. It was quite a challenge to search for the first one, even though Einstein's theory of relativity predicted they were common. Unlike stars, dark openings do not emit any light on their own. Their size and spin are the only measurable properties we have visual evidence of. Dark openings confirm their existence has only recently been possible, but definitive proof of dark openings was lacking for quite some time. The first dark opening, Cygnus X1, was found in 1964, but it took over 30 years for experts like Stephen Hawking and Kip Thorne to reach a consensus on whether Cygnus X1 was indeed a dark opening. Hawking, a prominent figure in dark opening research, was certain of their existence yet cautious about the lack of conclusive findings. Hawking and Thorne were nearly 100% sure that Cygnus X1 was a dark opening in 1975 when the bet was first made, and by 1988 they were 95% sure. Still, Hawking held on until 1990 to concede defeat when more observations provided sufficient evidence. The initial discovery of Cygnus X1 was made using 2 Geiger counters launched into space on a suborbital rocket, detecting a signal pinpointed to a system 7,200 light-years away. The system included a blue supergiant star orbiting another massive object emitting strong X-rays, which would make sense if it were a dark opening. Much research has focused on Cygnus X1 since its discovery, revealing that it is 21 times the mass of the Sun, making it the largest stellar mass dark opening found without gravitational waves. This discovery challenges long-held assumptions about dark opening formation and the mass loss experienced by stars over their lifetimes. Cygnus X1 breaks records in more ways than one. Its extraordinary mass and the fastest rotational speed of any dark opening found so far, approaching the speed of light, defy the accepted pattern of dark opening evolution. Although definitive proof of dark openings has only recently been found, it is increasingly clear that they are scattered throughout the universe. Even if researchers eventually unravel all the mysteries of Cygnus X1, the first of its kind, countless others still hold many surprises. Under 2,000 light-years from Earth, researchers have found a dormant monster, the Milky Way's largest stellar dark opening, Gaia BH3, with a mass 33 times greater than that of our Sun. Despite being the second closest known dark opening to Earth, Gaia BH3 remained undetected until recently. Gaia BH3 was discovered accidentally while researchers from the European Space Agency examined data from the Gaia mission, which maps our galaxy in 3D. The discovery of this dormant dark opening, which is not actively siphoning energy and materials from a companion star, was a complete surprise. Typically, stellar dark openings in our Milky Way have a mass 5 to 15 times that of the Sun, with Cygnus X1 holding the record at 21 times the Sun's mass. However, Gaia BH3, with a mass of 33 solar masses, is still small compared to all dark openings. For example, the central supermassive dark opening in our galaxy, Sagittarius A*, is 4 million times larger than the Sun. Gaia BH3 is the second closest dark opening to Earth, behind only Gaia BH1, which is 1,500 light-years away and 10 times the mass of the Sun. Astronomers now have more evidence to piece together how stellar dark openings form from the death of large stars with lower concentrations of heavy metals. These metal-poor stars, primarily composed of hydrogen and helium, are believed to experience slower mass loss, leaving more material available to create gigantic dark openings when they die. Using the James Webb Space Telescope, JWST, Astronomers have found an incredibly red, supermassive dark opening growing in the early universe's shadow. As the universe expanded, the supermassive dark opening took on a reddish hue 700 million years after the Big Bang. The light traveling our way is redshifted, suggesting a dense shroud of gas and dust surrounding the dark opening. Lucas FCK and Eyal Zitrin of the Ben-Gurion University of the Nejev's astronomy team established the supermassive dark opening's mass using JWST data, finding it to be around 40 million times the Sun's mass. This discovery starkly contrasts with the galaxy it inhabits, showing that the supermassive dark opening is rapidly consuming the surrounding dust and gas. Located around 12.9 billion light-years from Earth, this quasar, as the object was first identified by its red appearance, was made when a large amount of matter surrounded a supermassive dark opening, forming a disk of gas and dust that feeds the dark opening. The massive gravitational impact of the dark opening stirs up this matter, generating intense temperatures and making it glow. The light emitted by quasars can be so bright that it surpasses the brightness of all the stars in their surrounding galaxy. The JWST identified this supermassive dark opening as a small point due to the enormous amount of radiation it was emitting. The object was identified as a peculiar star-forming galaxy based on color analysis, supporting the hypothesis of supermassive dark openings. Its small size and apparent supermassive dark opening nature stood out from other quasars found in the early universe. This discovery was made possible by gravitational lensing, an effect predicted by Einstein in 1915. Einstein's theory of general relativity suggests that objects of mass bend the fabric of space and time, which are combined as a single entity called spacetime. This curve causes gravity to exist, and the more massive the object, the more extreme the shape. The shape of spacetime also affects the light emitted by stars, bending it as it passes near massive objects. This phenomenon, known as gravitational lensing, allows us to see distant objects that would otherwise be invisible. The JWST used this effect, aided by a galaxy cluster called Abell 2744, to magnify the radiance of distant galaxies and reveal the dark red quasar. This new information adds to the growing body of evidence that the early universe was populated with supermassive dark openings, which can be millions or even billions of times heavier than the Sun. Now that this behavior has been observed in several additional early universe supermassive dark openings, it sheds light on the formation of both the dark opening and the host galaxy, as well as the connection between the two. The classic chicken or egg problem on a cosmic scale is still unresolved. Did the galaxy or the dark opening come first? How large were the first dark openings? And how did they grow? Experts may have found evidence that microquasars, which are vampire dark openings that consume companion stars, are cosmic particle accelerators unleashing unexplained high-energy cosmic rays that hit Earth. These supermassive dark openings consume material from neighboring massive stars in binary systems, and some of the star matter is ejected as relativistic jets traveling at extreme speeds. Microquasars are smaller versions of quasars, both powered by supermassive dark openings devouring nearby matter. Discovered in 1912, cosmic rays can hit Earth with energies reaching 10 to the power of 20 electron volts, far more energetic than particles accelerated at the Large Hadron Collider, the world's most powerful particle accelerator. The hypothesis suggests that supernovae and microquasars are the universe's most powerful cosmic particle accelerators. However, evidence of microquasars accelerating particles to such high energies has been scarce until now. Using the High-Energy Stereoscopic System, HESS, researchers identified extremely high-energy gamma rays from the jets of the most powerful microquasar in the Milky Way, establishing the connection between cosmic rays and microquasars. This microquasar, SS433, produces high-energy cosmic rays through its jets, which collide with surrounding matter, creating a shock front that accelerates electrons to extreme speeds. These gamma rays are a byproduct of this process. SS433 was the first microquasar ever discovered, located at the center of the W50 supernova remnant, affectionately called the Manatee Nebula. SS433 has been the subject of extensive research for decades. The system consists of a white supergiant star and a dark opening about 10 to 20 times the Sun's mass. They orbit each other every 13 Earth days, with the star's outer layers being stripped by the dark opening's gravity. Some of this material forms an accretion disk around the dark opening, while other parts are ejected as jets traveling at 26% of the speed of light. These jets, spiraling in a corkscrew pattern, shape the W50 supernova remnant, giving it the appearance of a cosmic manatee. The jets fade over time but reappear, a phenomenon driven by the recurring nature of SS-433's behavior. The discovery of high-energy gamma rays emitted by SS-433's jets supports the idea that the source of these cosmic rays is particle acceleration. SS-433 is now considered the closest object accelerating particles to extreme energies in a supernova remnant. This hypothesis explains the origin of the enigmatic cosmic rays that hit Earth, which could help astronomers uncover the history of the universe and dark openings. A black hole is a fascinating and complex cosmic phenomenon that draws attention from scientists and the general public alike. It remains a major focus in astrophysics, as researchers continue to explore and expand our understanding of these mysterious entities.